Hi everyone, welcome to our webinar today. The topic for today's webinar is Income Trends of Residential Solar Adopters. This webinar is being presented by the Clean Energy States Alliance as part of our Sustainable Solar Education Project. And we have with us on the line some excellent guest speakers from Lawrence Berkeley National Laboratory. We also have with us our host for today's webinar, Diana Chase. Diana is a program associate here at the Clean Energy States Alliance. Before I pass it over to all of those excellent presenters, I'd like to go over a few quick housekeeping notes. So you have a couple of options to join the audio portion of today's webinar. You can use your computer, mic, and speakers, or you can call in using your telephone. If you'd like to minimize your webinar console so that you can view the presentation full screen, you can click on the little orange or red arrow that you see circled there. You can also use that button to expand the webinar console. Another very important note, we ask that you please submit your questions and your comments as you think of them by typing them into the question box on the webinar console and hitting send. We're going to get to as many questions as we can. We're saving about 15-20 minutes for Q&A at the end of the presentation. So please do submit your questions. Do it when you think of them, and don't wait until the very end to type those in. We are expecting to have a lot of people on the line, and that means probably a lot of questions. So we'll get to as many as we can, but we'll be able to get to yours with more certainty if you type it in sooner. And a final note, this webinar is being recorded. We will send you an email in about 48 hours, maybe even this afternoon, with a link to all of the webinar materials, the slides, and the recording. And we'll also be posting those on our website at cesa.org/webinars. So with that, I would like to turn it over to our host for today's webinar, Diana Chase.
Thank you, Samantha. As Sam said, I'm Diana Chase, and I'm a program associate here at the Clean Energy States Alliance, or CESA. We're here today to talk about income trends of residential solar adopters. But first, let me just briefly introduce you to CESA. We are a coalition of public energy agencies, mostly state agencies from around the country, working together to advance clean energy. You can see our members here. We're presenting this webinar today as part of our Sustainable Solar Education Project. The Sustainable Solar Education Project, which is funded by a grant from the U.S. Department of Energy Solar Energy Technologies Office, provides information and educational resources to help states and municipalities ensure distributed solar electricity remains consumer-friendly and benefits low and moderate-income households. The Sustainable Solar Education Project provides guides, webinars, and other resources. It also has a free monthly newsletter highlighting news from around the country on solar consumer protection and equitability. You can find all of these resources at the link at the bottom of the screen. Today's webinar features Galen Barbos and Naeem Dargouth from Lawrence Berkeley National Laboratory. Galen and Naeem recently released a report analyzing income trends of residential solar adopters in states across the U.S. and how equitably solar growth has occurred across income groups. And if we can advance the slide, you will see that there's a link to their report at the bottom of the screen. Today they will discuss their findings. Galen and Naeem will speak for 35 minutes or so, and then we'll have some time for questions. I'd like to introduce our speakers. Galen Barbos is a research scientist in the Electricity Markets and Policy Group at Lawrence Berkeley National Laboratory. Galen has worked at the lab for 17 years, conducting research on issues in the electricity industry involving renewable energy, energy efficiency, and electric system planning. Galen is one of the principal investigators leading the group's solar energy-related research activities, with a focus on PV system pricing dynamics, adoption trends, and utility rates and regulatory policy. Dr. Naeem Dargouth is a Senior Scientific and Engineering Associate in the Electricity Markets and Policy Group at Berkeley Lab. Naeem conducts research and analysis on renewable energy policy, both U.S. and international, including electricity rate design and its impact on the value of residential renewable energy systems, economics of renewable energy technologies, and federal and state energy policies. And with that, I'll turn it over to Galen. Galen?
All right, thanks, Diana. Good morning, good afternoon, everybody. Really happy to be here and to be able to share this work with all of you. So I am going to just kick things off here and kind of introduce the project a little further before handing things over to Naeem, who will really walk us through the bulk of the presentation. Before doing so, I do just want to extend thanks in several directions. First to Diana and Samantha and CISA for hosting this webinar. In addition, this project here was conducted in part under the auspices of a State Energy Strategies grant project that CISA led and that involved the participation of 6 states, or really five states in the District of Columbia. So I certainly want to thank all of the participants in that project who provided lots of valuable input and guidance on the work that we provided here, or that we're presenting here. And then lastly, of course, want to thank the Department of Energy Solar Energy Technologies Office for supporting this work, without which we, of course, would not be here. So Naeem, if you want to just progress to the next slide here, and then go one further. So I'm just going to give a very quick background overview on the project. So the basic objective of this work is to present some basic descriptive trends on the income characteristics of residential solar or photovoltaic adopters in the United States. As you'll see, many of the trends that we present kind of focus in on low and moderate LMI households. Others have conducted similar kinds of studies over the past few years looking at income characteristics of solar adopters. So we're certainly not the first ones to really kind of look at this issue, but several things sort of make what we've done here somewhat unique. The first is that while many of the previous studies out there have relied on kind of aggregate level income data, so either census block median incomes or zip code average incomes in order to characterize the incomes of individual solar adopters, what we've done here instead relies on household level income estimates. And these income estimates come from a company called Experian, and Naeem will provide a little bit more detail on those data or those estimates. We're dealing with fairly high resolution income estimates here at the household level. The other unique aspect is the relatively extensive coverage of the data that we're using for this analysis. So the trends that we'll present are based on the latest edition of our Tracking the Sun report and the underlying data set. And that data set covers a little over 80% of all residential and non-residential systems in the US. And importantly, it has street addresses for a little over 60% of the systems. And it's really that 60% or so that forms the basis for the analysis that we'll present here. Before handing things off to Naeem, I do want to just note a few limitations to the scope of this analysis. And those limitations also help to illustrate some areas of potential further exploration. So the first is that our focus here is on rooftop solar for single family homes. And that focus is really just dictated by the underlying data. Of course, especially when looking at LMI households, multifamily homes and community solar are both also important segments. We haven't included those here for data reasons, but certainly that's an area that's ripe for further exploration, and we hope to do so in the future. In terms of the time frame of the analysis, we're looking at systems installed through year-end 2016. Again, that's really just kind of derivative from the data set that we're using. And we're looking at systems installed across 13 states. So those 13 states include the 6 that were part of this State Energy Strategies grant project, as well as, of course, a number of others, among which are some of the larger state markets. And then last, our focus here is really on just laying out kind of basic descriptive trends, the facts on the ground, as it were. As we go through these trends, we can sort of offer some suggestions and hypotheses about the underlying drivers for the trends that we observe, but that's really not the focus of this analysis. And certainly we plan and hope to do kind of further work in this area that might delve into these trends a little bit more deeply with some more kind of sophisticated statistical methods to really try to tease out some of these underlying causal factors. So with that, I am going to hand it over to Naeem, who will take us through the heart of this report.
Great. Thank you so much, Galen. My name is Naeem Dargouth, and I will kind of lead us through the data, which is kind of one of the unique parts of this analysis, before getting on to the results, which I'll then hand it over back to Galen to kind of discuss the conclusions before the Q&A session. So the principal data set we use is from the latest Tracking the Sun study, which includes data on about 1.1 million residential and commercial systems. Most of those are residential. And we have addresses for over 800,000 of those PV systems. So in this analysis, we focus on 13 states which have strong address level coverage. And these include some of the larger PV markets, as we see on the right here, namely California, Massachusetts, New York. And all of this represents just under 60% of the US residential installs in 2016, and just above 60% of cumulative US residential installs. So some of the notable state markets that are missing from this data include Arizona, Colorado, Hawaii, Maryland, and New Jersey, and this is simply because address level data hasn't been shared. So one of the main differences with other analyses that have been conducted in the past is that we used a household level income, which we received from Experian, which, as you probably know, is one of the 3 large credit bureaus. So to get access to these income estimates, we signed an NDA with Experian, and we sent Experian all the standardized PV addresses from the Tracking the Sun dataset. Experian was then able to match about 77% of those PV addresses to exact households or persons. And for most of the remaining addresses, they may not have had these household-specific estimates, but they were able to match the address to a ZIP+4 level. And a ZIP+4 is basically one side of one block of a street. And then we're able to provide average income information for that ZIP+4. And very few addresses were not matched at all by Experian. So Experian provided a number of variables, but most importantly, household income. And this household income is modeled from Experian survey data and then calibrated to the census income distribution at the block group level to ensure that their distributions coincide well with the census data. In the full deck, we also include a slide looking at the Experian data in more detail, and it does indicate some potential issues around these income estimates, especially at the lower end of the spectrum, and this could be a result of a number of factors. So we also make extensive use of data from the US Census in order to characterize income and other demographic variables for the broader population, so including non-PV as well as PV adopters. And the census data was downloaded from Fact Finder, the online website where one can download a number of variables. We used the 2016 version of the American Community Survey, the 5-year averages, and we use census data variables that correspond to the Experian variables we use, and this will include household median income, household income distributions, the owner-occupied versus renter distributions, which I'll be discussing in a bit, as well as single versus multifamily numbers from the census. And most of these variables are available at several geographic resolutions, the smallest being the block group, which is about 600 households, and then increasing in size depending on the geographical scope of our analysis. Because we have geocoded each PV system with an address, we're then able to match each of these to a census block and to these larger areas. And one important thing to note here is that we'll be talking about low and moderate income, and low and moderate income, or LMI, is often determined relative to the household's area median income. And that is the median income in the metropolitan statistical area, which is calculated directly from the census data, and I'll be discussing this a bit more later on when we turn to LMI results. And one final note here is, as I mentioned, because the Experian data is fit to the census data, we can confidently compare the Experian data for the PV adopters to the census data for the broader population. So before we dive into the long-awaited results, I'm going to make a quick comment on defining what the reference population is. So what are we comparing the PV population to? And throughout the results I'm going to be presenting, PV adopters are compared to this reference population. Depending on the geographic scope of the analysis, we use different reference populations. So for example, a lot of our analysis looks at state-level populations, as well as those for the collection of states in our sample, whereas our LMI analysis uses the metropolitan statistical area as a reference population, since those are the areas that define area median income, which are used in as a threshold for low and median income. So in addition to geographic scope of the reference population, we can also define the reference population in terms of owner-occupied households rather than all households. And so this Venn diagram here on the right shows the different combinations of populations that could be used as reference populations. Given that most PV adopters tend to be in single-family owner-occupied households, ideally we'd make use of the single-family owner-occupied broader population as a reference, but the census data doesn't really provide income or other demographic data for that subpopulation. So finally, let's delve into the results. Let's start with the most kind of basic result. And in summary, we find that the median income of all PV adopters in our sample is significantly higher than for all households. But if we compare to owner-occupied households, that difference shrinks. So the chart here on the left shows the median incomes across the 13 states in our sample. To calculate this for PV system PV adopters, we weight each of the state median incomes, for the overall numbers, so the all households and all owner-occupied households, we weight each of the state median incomes by the appropriate number of households. So we see that the residential PV adopters have a mean household income of $92,000 a year, and this is 54% higher than for all households in those 13 states. However, most of that difference is attributable to home ownership. So I should note that home ownership rates are much higher for households with incomes above the state median than below, and many of the PV owners are a homeowner. So this is likely a result of the standard kind of split incentive barrier, which is endemic to distributed energy resources generally, including solar, but others as well, such as energy efficiency. The median income of PV adopters is 17% higher than that of all owner-occupied households, as we see by comparing the blue and orange bars in the figures here. And the gap we see here is in large part because many of the PV adopters are in relatively high income states, and that pulls the median income of PV adopters upward, whereas the medians for all households and owner-occupied households reflect the distribution of the broader population in those 13 states. So if we look at the same set of results, the same set of 3 kind of bars, but at the state level, we find that qualitatively the trends tend to be similar across the states, with greatest differences between PV adopter and the broader population being in those states with lower statewide incomes. So indeed, median incomes for PV adopters are 30 to 70% higher than for all households. And similar to the overall sample numbers we saw in the previous slide, the differences in the median incomes are consistently much smaller when we compare PV adopters with owner-occupied households only. In fact, there are a few states, as we see here to the left of the figure, Connecticut, DC, and Massachusetts, where the median incomes for PV adopters are lower than for all owner-occupied households. And we should note that these are all states with relatively high state median incomes. In states with relatively low statewide incomes, PV adopter incomes are also lower, but perhaps not to the same extent as the overall population of owner-occupied households. So it's also important to understand how some of these median income trends for PV adopters have changed over time. So the main finding in this slide here is that annual trends show that PV adopter incomes have been falling and converging towards the median income for the broader population over time. So in particular, PV adopter income was 27% higher than that of owner-occupied households back in 2010, and this difference has fallen to about 10% by 2016. So although the aggregate PV adopter median incomes across all states shown here is heavily drawn from California, since that is by far the largest state in our sample, most states show a similar downward trend since 2010. And that state downward trend is exactly what we see in this slide here. The general trend has been lower PV adopter incomes with time. However, there are a few states that show a lower or even a slight increase in PV adopter incomes. Though, as we can see in the slide here, those states tend to be ones that had lower PV incomes to start with back in 2010. In this slide, we show that PV adopter median incomes in 2016 are greater than other owner-occupied households, though 4 states have reached so-called income parity, where by that we mean PV adopter income is equal to or even lower than median owner-occupied incomes. So the figure here shows the ratio of median PV income to median income for all owner-occupied households. So for our full sample, this ratio is greater than 100, as we see in the leftmost bar, but there is quite some variation in that ratio by state. So PV adopter median incomes range from 68% to 132% of the median income for all owner-occupied households. And the 4 states which reached what we call income parity are DC, Massachusetts, Connecticut, and California. Though, right, DC is not a state, so I guess it's 3 states and a territory. So for the reasons I discussed before, this variation in results across states is associated to the overall median income of owner-occupied households. We see this in this figure here, since we've ordered the states by decreasing owner-occupied household incomes, we generally see an increasing trend in this ratio size. So this slide here shows information on the distribution of incomes among PV adopters by state, and shows that moderate income households actually constitute a sizable share of PV adopters. We've also included on this figure to the left the percentage of PV adopters below 200% of the federal poverty level, those red circles, as well as the percentage of PV adopters that is in the range defined by the Pew middle class. Those are the orange circles. And we see some differences among the states, though those differences aren't very significant. And I should note that there are questions, as I mentioned before, about the income estimates at the lower end of the income distribution. So we should be cautious about interpreting the percentage of PV adopters under 200% of the federal poverty level in this figure here. If we look at time trends again, this time looking at the distribution of incomes of PV adopters over time, we see that over the last 6 years or so, since 2010, PV adoption has been trending towards more moderate household incomes. The figure here is similar to the previous chart we saw, but by year and for all states in our analysis sample. In fact, the rightmost bar, the 2016 bar, is equivalent to the one we saw in the previous figure. So there are two trends that we should note in this figure. First is before 2010, when we still had a relatively small residential PV market, PV adoption actually became increasingly skewed towards higher incomes, as we see from the increasing size of those blue and yellow bars in the chart through to 2010. However, since 2010, we can clearly see the opposite trend. The share of PV adopters from incomes less than the 60th percentile has been increasing steadily through the final year of our analysis. Now, this trend is driven in large part by California. As I mentioned, California is our largest state in the sample, but we do see similar trends since 2010 when we look at individual states. And we've included that in the slide in the appendix in the online deck, and if interested during the Q&A session, we can look at those as well. So many of the prior studies that have been looking at PV adopter income trends, as Galen mentioned, have either used median zip code incomes, because perhaps they didn't have access to PV addresses, or median block group incomes due to the lack of household level income data. So along with being geographically diverse, one of the novelties of this analysis is that we make use of household level incomes for PV adopters. So a fair question one may ask is, how different would these results be if we didn't use the Experian data, but instead used data from the census, either at the block group level or even rolled up to the zip code level? And we try to answer this in this figure here and find that the income distributions look really materially different when we use Experian data versus the census data. So the figure on the left here breaks up the percent of PV adopters that are in each of the state income quintiles using this different geographic scope of analysis. And it shows that the 2016 PV adopter income distribution across using the Experian data is different than the two using the census data. And the main differences are, the first difference is a greater representation among the tails of the distributions, so the 0 to 20th percentile as well as the 80th to 100th percentile. And this is a result of averaging that will occur across all households in the block group or zip code. And the second difference we see is a shift in the distribution towards the higher income households. And what this indicates is that PV adopters are likely to be in higher income than the other households in their block group or in zip code. So in their neighborhood, people or households that install PV tend to be higher income than their neighbors. So now let's turn to trends looking at low and median income households only. So until now, we've been only looking at trends in the incomes of PV adopters compared to the statewide incomes. And here we're going to focus on this LMI PV adopter as a group. to compare adoption rates within the LMI group, as well as explore some of the PV characteristics of LMI customers and compare those to non-LMI customers. So the first thing we should do is define a PV adoption rate. And this is simply an estimate which we come up with by dividing, or we take the cumulative number of PV adopters divided by the total number of applicable households. And we estimate adoption rates among all households, as well as among owner-occupied households. And we compare the LMI adoption rates to the overall PV adoption rates to be able to say something about whether LMI adoption is lagging or not behind the rest of the market. And in defining, of course, the LMI adoption rates, we need to define what LMI is. What is a low and median income? And here we use the area median income as a threshold value for defining LMI. So many states will use different definitions for LMI. And a percentage of AMI is often used as a threshold value, going from 60% to 120% of the area median income. In this analysis, we use 100% of the area median income as our default threshold, but we're also going to be presenting some results that vary with varying definitions. I'm not going to go into great detail on this slide, and there's arguably a lot going on, but the general message here is that we see that PV adoption rates by LMI customers are generally lower than that of the broader market, though this difference is lower when we focus on owner-occupied households only, and the most recent installs, 2016. So the left and right hand panels, so the left and right halves of this figure, show the PV adoption rates for cumulative and 2016 PV installation, respectively, among all households and owner-occupied households within each of those panels. So most generally, we find the results here reflect our earlier comparisons between median and PV adopter income distributions. In aggregate across all states in the sample, the LMI adoption rate is below the overall market adoption rate. And this gap, however, is smaller for a more expansive LMI definitions. So for those definitions, let's say 100 and 120% of AMI as thresholds in the gray and yellow bars. When looking at state level results, we find that LMI adoption rates also tend to lag the broader market, but to different degrees. So the figure here on the left shows a ratio of LMI adoption rate to the overall adoption rate for 2016 PV installs in the blue bars, and the LMI adoption rate in the red circles on the right-hand y-axis. The annual LMI adoption in 2016 vary widely across states, so those are the red circles, from less than 0.01% to 1.8% of owner-occupied households in 2016, when we define LMI as less than 100% of the area median income. And these numbers represent 70 to 90% of the overall state adoption rate, though the LMI rate is near or above the market rate in several states, and these states all have higher absolute income levels. So this dynamic is further accentuated in DC, which kind of stands out in this figure, as DC is part of a larger metropolitan statistical area that includes very high income areas of Virginia as well as Maryland, and this further kind of raises the absolute income threshold for LMI in DC. Now, the final results slide that I will be presenting before handing it over to Galen looks at the characteristics of the PV systems adopted by LMI PV adopters compared to non-LMI PV adopters. And what we find is that LMI PV systems tend to be smaller in size and more likely to be third-party owned, though we didn't find any kind of systematic differences in system price, module efficiency, or whether the systems use microinverters. So the charts here show various PV system characteristics for systems that are adopted by LMI households in the yellow bars and non-LMI households in the green bars. And then again, we define LMI in this case as less than 100% of the area median income. So we found that the median PV system size is about 5.4 kilowatts for customers that are identified as LMI, whereas it's about 6.2 kilowatts for PV customers that are in the non-LMI group. And this makes sense to some extent since larger systems cost more and lower income households may be constrained financially. And as well, higher income households also tend to have more electricity consumption to displace with their PV system, and so they may choose larger PV system sizes. The second significant difference we found was third-party ownership of PV systems. Whereas 57% of LMI customers have TPO or third-party owned PV systems, only 48% of those non-LMI PV systems have TPO or third-party owned systems in the year 2016. And this may be because wealthier or higher income households may have greater access to cash savings or financing to purchase their system outright. Clearly, third-party ownership has been important to the LMI customer segment, even if credit scores may limit access to TPO systems. So with that, I'm going to turn back to Galen, who's going to walk us through some of the conclusions before getting to the Q&A session.
Okay, great. Thanks, Naeem. So yeah, just real quickly, I thought I would take a moment to kind of step back. Naeem, did a good job just sort of laying out the basic descriptive trends. I thought I would try to kind of abstract a little bit from those specific trends and highlight some kind of broader themes that emerge from this work. So the first is that the choice of data and metrics obviously matter quite a bit. We saw that in the slide that compared the income distribution when using the household level data from Experian versus the aggregated census data at the block group or zip code level. We saw that when comparing PV adopters to the broader population, depending upon whether that broader population was all households or just other owner-occupied households. So certainly the story that one can tell when doing this sort of analysis is very much impacted by the underlying data and the choice of metrics that are used. So secondly, and kind of related to the above is, it's clear that home ownership is really one of the major drivers behind the differences that we observe in the income of PV adopters and the broader population. We saw that when comparing median incomes at the beginning of the presentation. We saw that in the latter half when looking at adoption rates. So clearly, home ownership is a big driver, and that isn't surprising. And it just reinforces the importance of business models and programmatic initiatives that are aimed at renters. If the goal is to try to expand solar access to LMI communities. Third is that PV adopters are not a monolithic group when looking at their income and demographic characteristics. There's quite a bit of diversity there. Of course, as a whole, their incomes do tend to skew higher than the broader population, at least when looking at all households as the point of comparison. But clearly, there are a large contingent of PV adopters that are from more moderate or middle income groups. And so that's just kind of an important thing to keep in mind as we sort of assess the state of this market. Fourth is that PV adopters income and demographic characteristics are definitely evolving over time. We saw that in some of the time trends where we observed that at least since 2010 or so, PV adopter incomes have been trending towards more moderate income groups. And some of what's going on there, of course, is that PV is just getting cheaper, and so it's becoming more accessible by virtue of that. As Naeem mentioned, the sort of expansion and proliferation of third-party ownership and other financing vehicles has probably helped in that regard as well. And then, of course, we've seen, especially in the past year or two, really an expansion of efforts at the state and local level to launch programs that are really specifically trying to target lower and more moderate income households. And so given all of those drivers, it could be important to periodically check back and kind of reassess the state of this market. And it's just important to kind of update the analysis every now and then. And then finally, we see quite a bit of variation in the income characteristics of PV adopters across different states and regions. Part of that, a big part of that, is just broader differences in income characteristics. So wealthier states tend to have wealthier PV adopters, is kind of an obvious one. But there are certainly other kind of local and regional dynamics as well, and especially given the kind of the growth of LMI-oriented programs over the past few years, it could be important going forward to really try to understand the influence of some of these local and regional drivers. So with that, maybe Naeem, if you could just go to the next and last slide here, where we list our contact information. So we got, it looks like a good 20 minutes for Q&A. Certainly if we're not able to get to everyone's questions, folks should feel free to email either Naeem or myself. We'll also just point you here towards some other vehicles for obtaining information, our general publication page, and then importantly, our email list if you want to receive notifications of future work in this area. So with that, I will just thank you all for listening in, and I'll hand the baton back to Diana to take us through the Q&A.
Great, thank you, Galen and Naeem. We do have a bunch of questions, and I would encourage anyone else who has a question to go ahead and type it into the question box, and I will get to as many of the questions as I can. Our first question is, do you foresee the uptake in LMI adoption rates as compared to the median continuing into the future? How about the statistics around third-party ownership for LMI households?
Well, I can take a first crack at that question, and then Naeem should feel free to chime in as well. So, I mean, I think we can hypothesize here. I think there are certainly reasons to believe that the trends we've observed over the past few years will continue, but one never knows. There are other dynamics at play. So, obviously the fact that you've got many states, including the 6 that are involved in this project, but others as well, really starting to get serious about trying to expand access into LMI customer groups. I think that plays very favorably for expanded adoption within those income groups. Solar costs are also, I think, expected generally to continue to drop, though of course one never knows, and there are other countervailing factors. I think in terms of dynamics that might dampen those trends, I mean, one thing that is happening is reform of retail rate structures and net metering rules. Generally, those reforms tend to make the economics of solar a little bit more challenging. And so sort of, just as declining costs of solar tend to make it more accessible to lower income communities, regulatory reforms that make the bill savings less will have the opposite effect. So, you know, it's hard to say. I think if I had to make a guess, I would say, you know, some continuation of these trends will continue, but you know, we're sort of at, you know, on the verge of a new frontier in many respects.
And I would just add to that, you know, as we see more more programs that target renters in particular, given that a large number of the LMI population is are renters, programs that enable renters to participate into the market will kind of increase the LMI penetration rates.
Okay, great, thank you. Our next question is from someone who writes, I'd like to better understand how Experian models the household level income data, and what does calibrated to census block group or zip code mean?
So I can take an initial stab at this as well, and I guess maybe I'd begin by just caveating it by saying that you know, we're not experts in Experian's modeling methods. I mean, we did talk to the statisticians who developed their estimates and have a general understanding of how they develop these household level estimates. But I can only give sort of a secondhand description. So, you know, my basic understanding is that, you know, they have a bunch of household level data that are effectively the independent variables in a multivariate regression. And those variables include things like age, household size, I believe education level. I'm not sure how many variables they have, but they have quite a few at the household level, and then they use that information to basically predict the likelihood that any individual household will fall within one of, I believe, 12 different census income ranges. So they first do that, and then at the block group level, so the census publishes income statistics at the block group level, which I think Nain will correct me if I'm wrong, consists of on average about 600 households. And so what Experian will then do is they'll look at their estimates for all the households in a given census block and make adjustments so that the distribution of their household income estimates conforms to the census distribution at the block group level. And they basically do that for each individual census block group. That's my understanding.
Okay, great, thank you. Our next question is from someone who asks, can you make more detailed state-specific data available to policymakers from those states? And if so, is there someone that the question asker can contact to obtain that information?
Yeah, well, certainly, I mean, you can contact either Naim or myself. I mean, we're somewhat constrained in being able to just hand over data since much of it was obtained via confidentiality agreement, but there certainly are, you know, opportunities for us to help individual states if there are certain ways that you'd like us to kind of cut the data so that it might be more applicable to questions that an individual state's trying to answer. You know, we can often try to work with the state and figure out how to kind of leverage this data for those purposes.
And we should add, we did a number of state-specific analyses for a few states already, where we customized some of these analyses for individual states. So we have those ready for a handful of states, including Rhode Island, DC, Connecticut, Galen, what are the three others?
Oregon, Minnesota, and New Mexico.
Exactly. Yeah.
Okay, great, thank you. The next question is, slide 19 is confusing. Can you make any statement about what % of low and moderate income people have adopted solar compared to what % of the overall population have adopted solar?
So Naeem, I'll let you take this one.
Sure. All right. So I guess I do agree that there's a lot going on, and it is confusing. So what we have presented in the bars are the adoption rates for LMI adopters only. So let's look at the cumulative PV installations, and for simplicity, let's choose a single LMI threshold. So the gray bar, for example, presents a low and median income threshold that defines low and median income as less than 100% of the area median income. And so among all households, if we look at the PV adoption rate for low and median income using that 100% of AMI definition, we can say that 1.3% of all households are PV adopters among the LMI population. So again, if we divide the total number of PV adopters that are LMI by the total number of LMI households to get that 1.3% adoption rate. And that is lower than for all PV adopters. So if we look at all PV adopters, regardless of income, and divide that by the total number of households, the adoption rate is 2.2%. So in that case, we can compare the LMI adopter penetration rate, which is lower than the total PV adopter adoption rate. And so we've done that among all households, and that's the leftmost set of bars. We've also done that among owner-occupied households, and those bars are higher because the PV adoption rate is higher among owner-occupied households. And again, the denominator in that calculation is just the total number of owner-occupied households. And so the left side is for cumulative PV installations. The right side is only considering 2016 PV installations. And again, it presents the same sets of numbers. So hopefully that's kind of helped clarify what's going on in this slide.
Great, thank you, Naeem. Our next question is, you note that states like Connecticut and Massachusetts have higher income levels and a greater proportion of LMI adoption. Do you think that higher LMI adoption rates in those states could be a result of other factors, such as the existence of targeted solarized programs and financing programs in those states, like the Massachusetts Solar Loan Program?
Yeah, this is Galen. I'll start. So yeah, I mean, certainly it could be. We didn't look at that, so I mean, we can hypothesize as well as anybody. Certainly, both of those states have had dedicated programs for LMI, and so one would hope and think that they have somewhat higher adoption rates among LMI customers as a result. I would say though that when just we didn't really try to kind of unpack the drivers for differences across states, but to the extent that we did, it seemed pretty clear that the primary driver, or at least a very, very big driver, was just differences in overall income levels within each state. So, in states that have higher incomes overall, we tended to see a larger fraction of adopters in those states coming from the lower income quintiles. And the reason why is that customers in those lower income quintiles, on an absolute basis, they have higher incomes, right? Because those income quintiles are defined on a state on a state basis, and so PV is more affordable to them. So that, I think, just at the high level, differences in overall state level incomes seems to be the most obvious predictor in the differences across states in terms of some of the metrics that we're looking at here. But obviously, you know, other stuff is going on, and we really want to sort of dig into this data further to try to understand the impact of that other stuff. We do actually have a project that is underway right now, working with some students who actually are trying to understand, using some sort of more in-depth statistical methods, whether solarized programs, PACE programs, and third-party ownership have sort of differentially helped to accelerate solar access among LMI customers. And so that work is kind of still underway, so I'm a little hesitant to really declare any conclusions from that. But it does seem like, at least based on the analysis we've done so far, that solarized programs do seem to have had some benefit in terms of aiding LMI adoption.
Okay, thank you, Galen. We have time for a few more questions. Someone would like to know, is it possible to filter the data by utility districts to see the solar penetration in each district?
Well, it is, but our data, just to be clear, are not comprehensive. We don't have every single system. So, I mean, if one wants to know solar penetration by utility, the best way to do that is to pull EIA 861 data, which consists of total counts of residential PV systems by utility. So that I think if that's the goal, then that's probably a more useful data source than what we've got.
Okay. And our next question is, will you be able to track and analyze this data going forward so we can see if and how these trends continue?
We hope to. Yeah, I mean, it's all, you know, kind of contingent on funding and you know, other stuff like that. But yeah, we're hoping to continue doing this, tracking the sun, which is kind of the underlying data set that we used for this. That's an annual report, and it's a data set that we update every year. And so, you know, the hope is to be able to kind of continue leveraging that and kind of adding on this demographic piece, and hopefully, you know, publishing either on an annual basis or maybe somewhat less frequently than that, kind of updated statistics on some of these trends.
Okay, and here's our next question. How do you collect addresses to add to the Tracking the Sun database? For example, if a city issues permits for solar installations with street address, system size, installation date, project status, etc., would that be acceptable? And is there any validation needed, like cross-referencing to see if they match the number of installations reported to EIA?
Yeah, so I mean, certainly that kind of data would be useful. What the address data that we use for this analysis really comes via the Tracking the Sun data collection process. And the data sources for Tracking the Sun consist of mostly PV incentive programs administered either by state agencies or utilities. Some utilities that have phased out their incentive programs are still continuing to collect this data and provide it to us. Now, not all of that data comes with addresses. As one of the early slides in the deck noted, I think we've got addresses for maybe 3/4 or so of the systems in the Tracking the Sun data set. And so it really just depends on sort of whether the data provider has that information first, and then secondly, whether they're willing to share it with us under a non-disclosure agreement or otherwise. So that's kind of historically what we've relied on. I think as we start doing more of this demographics work, we've been thinking about expanding the underlying data set to pull in address level data from some other sources, and that would potentially include building permit data. There are a variety of private sector entities out there who are scraping building permit data and compiling it into data sets. And so we've been talking to at least one of those entities to see about potentially folding that in as well. And that does require some amount of cross-checking and validation, as the questioner suggested.
Okay, thank you. And I'm afraid we're running out of time, so we're going to wrap it up. And I apologize again for not being able to get to all the questions. Galen and Naeem, do you have any final points you want to make before we wrap it up here?
None from me, other than just to thank you, Diana, and thank everybody else for tuning in.
Yeah, absolutely. Thank you, everyone. And don't hesitate to get in touch with us by email if there are any further questions or the such. So thank you.
Okay, well, thank you very much to Galen and Naeem, and I will also say thank you to all of you for tuning into our webinar today. And I'm going to turn things back over to Samantha for some final words.
Great, thanks, Diana. Well, I want to let everyone know about an upcoming webinar that we have scheduled in June. You may be interested in this. The topic is electricity affordability metrics for the U.S. So that's on Thursday, June 14th at the same time as this webinar was today. So you can read more about this webinar and register at cisa.org/webinars. So we encourage you to look that up and sign up. So thank you everybody for attending today. We hope to see you at the next one.